Okay, so we are going to start off putting values into the calculator and filling into this table. So I just want to remind you that we can change our table in our calculator to ask for the independent variable. So if you're using a yellow calculator, you probably need to make that change. If you're using yours, it might still be like that from the last time we did it. So anytime you want to do a table of values, you're going to go to y equals, and then type in the function. Okay, and then I'm going to hit second window to get to table set, and I'm going to change it to ask for the independent variables because these decimals aren't going to show up on a normal table. You're going to have to tell it which ones you want. All right, and then we're going to go to the table, and then just plug in these values. So you guys fill in that table for me, please. Let's see. So what do you guys think is happening at x equals 2? What's going to be there? Vertical asymptote. Very good. So that's because nothing factors here, and you have this value of x that's going to give you 2 in the denominator. And when you plug in 2, you get you get 3 over 0. So that is a big clue that that's going to be a vertical asymptote. Now what we're going to do today is find some limits that are going to be equal to infinity or negative infinity. Now, technically, a limit doesn't exist at infinity, if it is infinity, but we can use infinity and negative infinity to describe what's going on the graph, and that's really what limits do, is describe what's going on the graph. So, if we are approaching 2 from the left side, which is going to be this side, what do you think the graph is approaching? Negative infinity. Very good. All right, and then we're going to approach 2 from the right side, and that's going to be positive infinity. So the title is to connect infinite limits and vertical asymptotes. So sometimes when you get a limit that equals infinity, it is describing a vertical asymptote. Now, there is one time when it doesn't, and that's, I don't know if we've had these yet, but sometimes the limit as x approaches infinity or negative infinity gives you that that infinity or negative infinity, and that's not a vertical asymptote. So if f of x approaches infinity or negative infinity as x approaches a real number, let's call that number c. So that's what I was talking about. As long as this value that x is approaching is a real number, then this is going to be a vertical asymptote. So from the left or right, then x equals c is a vertical asymptote. So tomorrow we're going to connect limits to in behavior, which is going to be slightly different. Okay, and so then over here I have the graph of this function, and you can see as you approach to from the left, the graph is approaching negative infinity. From the right, the graph is approaching positive infinity. Okay, now this is review, and this was actually on your quiz. So direct substitution of a rational function will yield something like 5 over 0 or negative 2 over 0 at a vertical asymptote. But what we're going to do now, instead of just saying that the limit does not exist, we're going to find one-sided limits you can find a one-sided limit to either infinity or negative infinity by plugging in one side of the vertical asymptote. So that's just to figure out like what's going on in the graph. All right, and then direct substitution of a rational function will yield 0 over 0 or indeterminate form. Add a hole or removable discontinuity. And what we're going to do is we further investigate by factoring or other algebraic method to find the location of the hole. We're not going to do that very much today, that part, but that's just a review of what you should do. Okay, so on example 1, we're actually going to use our graphing calculator to do most of this work. So we're going to use the graph and we're going to use the table. So this one is similar to the one we just did, but we're going to go ahead and type that into y equals. Now we're not going to try and type in limit. We're just going to type in the x over x minus 3. All right, so let's start with the table, and then I'll show you how to do it with, let's start with the graph, and then we'll talk about the table. All right, so we are going to approach 3 from the left side. I'm just going to do a little graph of, okay. So from the left side, what do you think the graph is approaching? Negative infinity. So we're approaching 3 from the left. The graph is falling, falling, falling. So that's negative infinity. All right, now if we want to do this with a table, what we're going to do is plug in a number close to 3 that is on the left side of 3. So I'm just going to plug in 2.9.
Are we going to want to do this little table for every pixel?
We're just going to do 1 point on the table. That's all we need. All right, so I'm going to clear out what was already there. You don't necessarily have to, but I just want to use the top. And then we'll just put in 2.9. If you get a negative, then it means negative infinity. If you get a positive, then it's going to mean positive infinity. So that's if you know there's a vertical asymptote there. That just shows you if the left side is going to be falling down or going up. Okay. So I'm going to put over here beside this 2.9 that was the left side of 3. That's why we chose 2.9. All right, so all of my students are probably going to be a little behind where we could be with secant of x and cotangent of x and cosecant of x because we didn't use the calculator, the graphing calculator at all. I'm sure you guys remember that. So what is the secant of x, the reciprocal of? Yeah. So secant of x is the same as 1 over cosine of x. That's how you have to type it in the calculator. And so you can do the alpha y equals little fraction guy if you want to. Or you can just do divided by. So on the graph, though, this is another thing we haven't done before. I want you guys to hit zoom, and then anytime it has something with some kind of trigonometry in it, we're going to hit zoom trig, which is going to be number 7. And that takes us to the independent axis is from negative 2 pi to positive 2 pi. And we're approaching pi over 2 from the right side. So each one of these tick marks is pi over 2. So this is pi over 2, pi, 3 pi over 2, 2 pi. So from that graph, what would you say the answer is? We're from the right side?
Negative.
Negative infinity. All right, I'm going to do a little graph so you can see what I'm talking about. That's not beautiful, but it's okay. Okay, as we approach pi over 2 from the right side, the graph is falling, falling, falling. So that's negative infinity.
What's the other side?
Well, if it asks for the other side, then that would be positive infinity.
That would be infinity.
Positive. Mm-hmm. So if we're going from the left side, it's going up, 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 so it would be positive infinity. Now on the table, we are going to want to choose something on the right side of pi over 2. All right, so if you're unsure what pi over 2 equals, it's half a pi, but you can just type it in. Okay, so what is a number on the right side of that number that's also pretty close?
1.6.
Good idea. All right, so we'll go to the table, figure that out. Now I know there's a vertical asymptote here, so if I get a positive, it's positive infinity. If I get a negative, it's negative infinity. And I got a negative. I'm not even going to write the number. I'm just going to put negative because that's all that matters. All right, so those are the 2 ways that you can use the calculator and find values, one-sided limits. Let's go ahead and do a couple more.
Why are there 2 C's?
Oh, there's not supposed to be. Let's fix that. Just a typo. You guys want to try C on your own? Why don't y'all do that? Okay, so from the graph, what would you guys say the answer is?
Positive.
Good. Now, what is a number on the right side of negative 4? So that is bigger. So it's on the right side. And then if you plug that in, you should get a positive, and that's going to be positive. All right, now D, I can type this in different ways. So those of you that learned trigonometric identities last year, do you remember what sine of x over cosine of x is? Tangent of x. So if you remember that, you can just type that in as tangent of x. If you don't remember that, then you just type it in as sine of x over cosine of x. So that's completely fine. However you want to type it in. Yeah, I think I might have messed this up. We might need to change what we're approaching.
No, it looks like it works.
Okay. We'll get a value for the limit, but it's not going to be infinity or negative infinity. I mean, we can still do it, but I'm going to make. Wait, does yours say 0 or does yours say pi over 2?
0.
Gotcha. Mine just has a mistake.
Versus 0.
Let's change it to pi over 2 from the left. Now we definitely could find the limit of 0. It's just going to be 0, but that doesn't really go with the lesson. All right, what did you guys say this one is? Once we fix it to pi. Yeah, positive infinity. All right, if we did a number on the left side of pi over 2, we could do 1.5. And when we do that, we're going to get a positive. All right, any questions on that? I feel like it's taking a while. All right, the backside is going to be a little more complicated because we're not told where the vertical asymptotes are, basically. We have to find them first. And then we're going to do the appropriate limits on our own. So it's okay. So to find the vertical asymptotes, what we would first want to do is go ahead and factor this function if it will factor. All right, and then the x plus 3's do need to cancel out. So what is it going to, where is your vertical asymptote going to be?
2.
Yes. All right, and then we kind of want to figure out what's going on with the graph, and we're not going to use the calculator on 1 and 2 here, or 3. So the two limits that we're interested in is the limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. Now, because I know there's vertical asymptote there, the answer to those limits should be either infinity or negative infinity. All right, so I'm going to start off with a number on the left side of 2. And I can plug it in to either function. I can plug it into the original, or I can plug it into the reduced function. I guess this technically isn't f of x anymore, but that's okay. So I know the numerator is going to be a positive 1 no matter what. If I plug 1.9 in for this x in the denominator, is that going to give me a positive or a negative? Negative. And then a positive divided by a negative, what's that going to be? A negative. So that means this is going to be negative infinity. Does that make sense? All right, we'll do it again with a number on the right side. So I know my numerator is positive. And then 2.1 minus 2 is a positive. So that's going to be positive infinity. All right, so that's how you do it without a calculator. All right, let's do a few more. You okay? All right. So let's just start off by factoring. Now, whenever I see the 5 minus x, I'm pretty sure that maybe, I'm not 100% sure, that I'm going to want it the opposite way as x minus 5. So I'm going to factor out a negative You may or may not need to do that when you're doing your own assignment. All right, so where's the vertical asymptote on this one? Thank you. All right, so we're looking at two limits. The limit as x approaches negative one third from the left of f of x and from the right. All right, so negative one third is negative 0.33333. So what's on the left side of that? What? Yes, I see. Understand you. All right, and then the right side could just be negative 0.1. Okay, so no matter what on these, my numerator is going to be negative. Okay, so when I put in negative 0.4, I'm going to get I'm going to get 3 times negative 0.4, which is negative 1.2 plus 1 is a negative. So when I divide that, I'm going to get positive. All right, when I put in that, I'm going to get negative 0.3 plus 1, which is going to be positive. And when I divide, I get a negative. All right, so this definitely can be very tedious without a calculator, but it's doable. Okay, the next two, there's going to be more than one vertical asymptote, so they're a little bit more tedious. But we'll start off by factoring again. Now, I love these when they work out where things cancel, but a lot of times they just don't. And so when nothing cancels, those are both vertical asymptotes. So there's actually 4 limits we're going to have to find on this one. Okay. So on the left side of negative 0.3, I'm going to put in negative 3.1. And I think it's probably about the same, but I want you guys to practice on putting this into a factored form because this is something that will come up quite a bit. But when I put negative 3.1 in for the numerator, what am I going to get? A negative. Okay. And then I'm going to put them individually into my factors. So negative 3.1 plus 3 is going to be a negative. And negative 3.1 minus 3 is definitely a negative. All right, so this ends up being a negative divided by a positive or a negative. Oops, I didn't mean to make it negative. All right, so it's a very tedious process, but we can do it. So when I do negative 2.9 in the numerator, it's a negative. Negative 2.9 plus 3 is a positive. You have 2.9 minus 3 is a negative. So in this case, I get a negative divided by a negative, which is a positive.
So why can't you just plug it into the table?
We're doing 1 through 3 here without a calculator. Yeah, you definitely could if it was a calculator question. All right, so then we have positive 2.9. So that gives us a positive in the numerator, a positive in the first set of parentheses, a negative in the second set. And we got all positives for 3.1. All right, any questions on that one? That's a lot of writing. I didn't give you too many of these to do. All right, the last one is going to be a calculator, and there are many, many, many vertical asymptotes on this one because this is just going to repeat a pattern over and over and over again every 2 pi. And so I am shortening it just to the just to the first 4 quadrants, so one time around from 0 to 2 pi. So let's look at, we could use some identities if you wanted to and simplify that down, but let's just go ahead and type it in the calculator like it is. All right, now we're only looking at this right here from 0 to 2 pi. So I have 2 vertical asymptotes, one at pi over 2 and one at 3 pi over 2. So this one we're going to have 4 limits again. But we're just going to use that graph and answer them real quick. All right, so you guys use the graph and you figure out if these are infinity or negative infinity, please. Right. So what questions do you all have? Okay. Let's write down your assignment. All right. So 13, 16, and 19 are calculator questions. All right. 27, 28, and 30 are no calculator questions. And then 31 and 34 are calculator. And I want you to shorten the domain to just between 0 and 2 pi.